Oh, good afternoon, students. So, in the last lecture, we have calculated P1 and P2. Okay. P1 and P2. Okay. So, PT is positive. So, assumed direction is correct. Here, assumed direction is wrong. It will be like this 68.1. And we have the loading on the structure 100 kilonewton. And here we have the UDL of 60 kilonewton per meter. Now, how the reaction you have to find out? It's very simple now. Here one reaction, here one reaction. We have A, B, C. So we have the load of 100 kilonewton and we have the moment. Sixty kilonewton per meter. We calculate the reaction by using equilibrium equation RA, RB1, RB1, RA. So this is 68.1 kilonewton meter. Correct? Then you find out the reactions. Here summation of Fy equals to 0. So Ra plus Rb1 equals to 100. Take a moment about this point. Taking the summation of moment out point A equals to 0. Find out Rb1. Okay. Then you find out Ra. You will get Ra and Rb. Similarly here, take a moment about this point. We have two moments. We can find out Rb1 and Ra by using a equilibrium equation. Okay, students. By using the equilibrium equation you can find out. Okay, so this is about the flexibility method. Correct. So we have done the analysis of this indeterminate structure by using the flexibility method. Now we'll see the next part is the stiffness method. Same numerical we will take because we have the values of. Okay. Okay. Now listen carefully. It is very important. I will not repeat again in stiffness method. So this is what it is, just opposite of this flexibility. Okay. So if you see the steps involved to solve the stiffness method, okay, that is called as the equilibrium method also. Here what we have to find out? We have to find out the kinematic indeterminacy. First step, you have to find out the kinematic indeterminacy. Correct? That is what the degree of freedom. So how many degrees of freedom? Just you tell me. how many degrees of freedom for this structure. Yes, how many degrees of freedom? Yes, students, how many degrees of freedom? In the first lecture, I
6.
6. Okay, how 6? What is the degree of freedom for fixed end? What is the degree of freedom for fixed end? Yes, what is the degree of freedom for fixed end? Yes, what is the degree of freedom for fixed end? I have already explained. You are not giving the attention to it. For roller support, okay, we have degree of freedom is 2. For hinged or pin support, we have degree of freedom is 1 because it can rotate. For fixed support, what is degree of freedom? Is 0. And for free end, what is degree of freedom? Is 3 now. Okay. So what is the degree of freedom for fixed support? Just now I have explained. What is degree of freedom for fixed end? 0. What is the degree of freedom for here? Okay, 2. What is the degree of freedom here? 2 again. Now this is as per. Now you see the assembly. So this is the fixed, correct? One end is fixed. That means this beam cannot move horizontally because here it is fixed and A, B, C are joined. So this goes minus, this goes minus. It cannot move horizontally because one end is fixed, correct? We are seeing whole system at one stretch, correct? So only degree of freedom here is 1 and here again 1. So what is the degree of freedom for this structure is, or kinematic indeterminacy is 2. Okay, students? Okay. Okay, now because yes, correct. For roller support we have 2, for roller support we have 2, and here we have 0. But if you see the whole structure, one end is fixed, so this structure cannot move in horizontal direction. That's why here 1 degree of freedom gone, here 1 degree of freedom gone. Only we have 1 and 1, 2 degree of freedom. So after find degrees of freedom, okay. So what is the next step? Identify the independent displacement. So what we will do, so we'll assign the displacement. So here this end can rotate, this end can rotate. So we'll assign the rotation, okay, and we'll give the coordinates. This is 1 coordinate and this is 2 coordinate. Okay, we have first identify the kinematic indeterminacy, that is degree of freedom. Along that degree of freedom, we have assigned the coordinates and we have taken the direction clockwise. Always you have to do assign the clockwise directions. Okay, remember these things. So what we have done, so this can rotate like this. Okay, there is rotation of the beam. That means here clockwise, here clockwise. That means okay. So there is a clockwise. Sorry. Okay. So this one, when we have assigned the moment. Okay. So clockwise means this will be like this, not like this. Okay. Okay. Leave it. So we have assigned the displacement. We have identified the displacement, and along the displacement, we have assigned the coordinates 1 and 2. It is clear. It is clear. Third step is clear. Yes, students, it is clear. Okay, now we'll move to the next one. After assigning the coordinates, so prevent all the independent displacement components to obtain the restraint structure. What is our formula to calculate this? What is the stiffness formula? Yes, stiffness is force per unit displacement. Per unit displacement. So what we are doing? We are calculating displacement, correct? So what is K inverse into P matrix? Remember this one. Okay. So this is our formula. That means displacement matrix into the K inverse. Okay. K inverse in bracket total load minus load at the coordinate. Correct. So this is our formula to calculate the independent displacement components. Now, so and for this one, so we have P equals to P dash plus P delta. Correct. P delta. Now, first, so what is the fourth one? Prevent all independent displacement components to obtain the restraint structure. That means whatever the rotation is there, we have to prevent so that it will act as a rigid. So that means, so we have prevented this rotation by making this is as a fixed end. This one also we have prevented by making the end fixed. Here also we have made a fixed support, and here we have also made the fixed support A, B, C. Now we have restrained this rotation at A by making fixed end. Here also by making fixed end we have restrained the rotation at B, and here also B. What is the loading? After restraining this beam, okay, so what is the sixth step? Determine the P dash of forces required at the coordinates in the restraint structure due to loads other those acting on the coordinates. Now there is no load acting on the coordinates, only there are other loads 160. So what we have to calculate? P dash. We have to calculate P dash. How will get the P dash? Now this is a fixed end, so we have the moment, fixed end moments due to the loading. M bar AB, M bar BA, M bar BC, correct? So what is the fixed end M bar AB? Yes, anyone? Fixed end moments. Yes, 1.5, 1.5, and this is 4 meter. What is the fixed end moments? What is the fixed end moments when the point load is at center?
WL by 4.
WL by 4, not correct. Your basics is not Up to the mark, students. So when WL by 4 will be there, it is simply supported and we have W and this load is what? WL by 4. Now our beam is like this. What is this moments? L by 2, L by 2. Yes? Anyone?
WL by 8.
Correct. WL by 8. WL by 8. Now next, again, if it is fixed, it is fixed. If there is UDL, W per meter run, what is the fixed end? Hmm?
WL square by 12.
Now again there is fixed end, again fixed end. We have W, A and B. What is this end moments? This end moments W,
WAB square by L square.
correct. Here W,
A square B by L square.
correct. Like this. Okay. Now what is MAB? WL by 8. So what is 100 into 3 divided by 8? How much quantity? What is the quantity? What is the quantity? Hmm. What is quantity? Yes,
37.5.
37.5. Now minus or plus? Can anyone judge? Minus or plus? Minus or plus? Can anyone judge? Minus or plus? Yes. Can anyone judge? Yes, student. Minus or plus? I told how we have assumed the coordinates and how we are getting the moments. If it is in the both are in the same direction, then we have plus. If it is in the opposite direction, then we have minus. So minus or plus? Yes. You try. If it is wrong, also no problem. Minus or plus? Both the sketch are with you only. Minus or plus? Yes, friends. Please reply. Minus or plus? Yes. If I told if it is wrong, also no problem. At least you try. Minus or plus? Yes, minus or plus? Negative. Correct. This is negative. Simple. We have assigned the coordinates clockwise, but due to the negative moment, we have the anti-clockwise here. So that's a minus. So simple. Similarly, now we have to find out B. So this one is what? P1 dash. Because at this coordinate 1 we have find out the external moment due to the loading. Now what is the P2 dash? We have 2 m bar BA plus m bar BC. Now what is 100 into 3 divided by 8? I will not give the sign, and here WL square by 16 into 4 square divided by 12. Now you tell me this quantity is positive or negative? This quantity is positive or negative? Sign. Sign convention for this one. MBA. Positive. Simple. So this is what we have assumed clockwise. So here also clockwise. So positive. Correct. Very good. And for this quantity M bar BC, M bar BC negative. Simple. This is a clockwise movement, but here we are getting anti-clockwise. So negative. So what is the value? What is the value? Yes, what is the value? Minus 42.5. Correct. So we got P1 dash P2 dash equals to minus 37.5 minus 42.5. So this is what one matrix. Correct. So this one we have find out. Correct. Now, so what is this one? What is this one? This one matrix is nothing but what are the loads. So if you see this definition, okay, calculate the net forces at the coordinate. Calculate the net forces at the coordinate. Now, in this numerical, there is no extra moment on the coordinate 1 and 2, correct? So that's why, so this P is 0, this P is 0 because there is no coordinate or sorry external moment applied at a joint, so that's why this becomes 0, this becomes 0. Now what we have to calculate? We have to calculate the stiffness matrix then. Stiffness matrix. Now next. Now to find out the stiffness matrix, okay, okay, these are the coordinates we have assigned. Now we have to find out the stiffness. Stiffness is nothing but force required per unit displacement. So what is the force? Okay, so we'll take a coordinate 1. Now, so if you apply the unit displacement along the coordinate 1, what should be this force? Okay, now you tell me what is K11 then? Yes, what is the K11? What is the K11? What is K11? Yes, students, you have this table. Tell me, what is K11? When there is rotation, now other end is fixed, okay, because we have made this is restrained structure, okay. What is K11?
For EI by L.
Okay, 4 ei by L, that is 4 ei by 3, correct. Now what is K11? So meaning is what is the movement along the coordinate 1 when we have unit displacement up at coordinate 1. So what is K21? So what is the force or moment, okay, at coordinate 2, at coordinate 2, okay. So what is, because this is fixed, because we have restraint. So what is the moment at this end? Yes, K21, what is moment at the end? Hmm. The other end is fixed. You have that diagram. Open that diagram. So rotation at one end, if other end is fixed, correct. So what is the moment at other end?
2 EI by L.
2 ei by L, correct. So that is what? 2 ei by 3. Positive or negative? So this is clockwise. So that's why positive, because we have assumed clockwise also. And at fixed end, same moment will be there. Okay, sign of this moment will be the same because it's clockwise. Half of this carry over moment will be the same clockwise. So here also we have clockwise. So that's why it is plus. Now the second one, now will allow the rotation, unit rotation at coordinate 2 clockwise. So what will happen? This is what the clockwise rotation, correct. So this is coordinate 2 and this is coordinate 1. So what is the K22? 3 meter, 4 meter. Now we have restrained this end also. This is restrained also. This is also we have restrained. So what is the K22? That is what is the moment at 2 due to the displacement at 2. We have 2 rotation at coordinate 2 due to this rotation for beam AB and for BC. For BA, how much? Yes, other end is fixed. The rotation at one end, when the other end is fixed, what is the near end moment? What is the moment at this end? Yes, what is the near end moment? What is this moment? Yes, simple. Other end is fixed. What is the rotation at one end? What is the moment? See, simple. You open this chart. For end, far end is fixed. What is the stiffness? Is yes. Now you tell me. Hmm. Tell me. What is K22? What is the moment at coordinate 2 due to the rotation at unit rotation at coordinate 2?
4 EI by L.
4 EI by L. So I will take L1 plus for L2. Again, same other end is fixed up 4 EI by L2. Now, sign conventions. So here, this gives us upward rotation. That means it should be a clockwise movement. Clockwise movement, positive. Here it is for this one, it is downward rotation. For this beam, if you want downward rotation, this movement should be a clockwise. So that's why positive. Both are positive. 4 EI by 3 plus 4 EI by 4. So that will be 7 EI by 3. Correct? Now, correct? Now, what is the K12? What is the rotation at this end? This is clockwise, so this must be a clockwise. Yes, how much? Half of that moment, 4 EI by L is this one, so this one will be 2 EI by L. Half of carrier moment will be always half. Sign is same, clockwise. So 2 EI by L. Sign is same, positive, so 2 EI by 3. Sorry, 2 EI by, correct? 2 EI by 3. Now, so we got the stiffness matrix K equals to K11, K12, K21, K22. So what we have here, 4 EI by 3, K12, 2 EI by 3, correct? 2 EI by 3, here 7 EI by 3. Okay students, have you understood? So at coordinate 1, so this is what? Clockwise. So here also clockwise. So half of that one is 2 EI by L1. So L1 is what? 3. 2 EI by 3. Okay students? Now, so the displacement components equals to inverse of stiffness matrix P minus P dash. P minus P dash. So we have two displacement, delta 1 and delta 2. That means at coordinate 1 and coordinate 2. So the stiffness 4 EI by 3, 2 EI by 3, 2 EI by 3, 7 EI by 3. Inverse of this one, here it will be a 0 0, minus 37, what is minus 37.5 and minus 42.5, correct? So what is, we have delta 1 and delta 2 inverse, that means 3 divided by ei is common. So in bracket 4 2 2 7 inverse of this matrix into 37.5 42.5. Now you solve this one, 3 divided by ei. What is the value? Yesterday I told how to use the calculator for finding out the matrix. So the first one, so we have to assign, correct? Can you see the calculator? Now it is visible. Correct, students? You can see the calculator. Now, so how I can use this one? So shift 4, correct? Shift 4. Then we have to go to the dimension. Then press 1. We have to assign this matrix as a mat A. So press again 1. So what is the rank of this matrix is 2 by 2. So 2 by 2 is 5. Then you press 5. Then give the two 7. The mat B. Repeat the procedure. Shift 4. Press 4. Then dimension. Press 1. Then for mat B, press 2. Then what is the rank of matrix is 2 by 1, 2 rows, 1 column. So for 2 by 1, press 6. Then give 37.5, 42.5. Okay. Come out. Press on button. So now it's very simple. Shift matrix. Now mat A is 3. Inverse of that matrix multiply by shift matrix, that is press 4. For mat B, press 4 is equal to. So what is we have answer is 7.3, 7.4 I will take, and next one will be 3 point. So I'll take 4, 3.95. So I'll take a 4. So what is delta 1 equals to 7.4 into 3, 22.2 divided by EI, and delta 2 equals to 12 divided by EI. Okay, students, you got this delta 1 and delta 2. Students, over calculations. Now, after getting the displacement, how to find out the reactions? Correct? Students, this is over. So this is displacement in terms of rotation, that is theta A, and this is in terms of rotation theta B. Correct? Okay, students. Okay. Okay. So after getting the displacement, how to find out the unknown? Okay. So now, so our basic numerical is like this. Now we have to analyze. That means we have to find out the reactions and the moment at the support. So, but now this is A, B, C. Now we got this rotation at A equals to 22.2 divided by EI, and rotation at B we got 12 divided by EI. Correct? Now we have to find out what is the moment MC. What is this moment? What is this reaction? What is this reaction? What is this reaction? How to find out? If you know this moment, so MBA equals to, what is that formula? Slope deflection method. The moment at this end is 0 because it is roller. So we have the moment here. Now MBA equals to M bar BA, yes, plus 2EI by L in bracket 2 theta B plus theta A minus 3 delta by L. Minus 3 delta by L. Now M bar BA, what is the fixed end moment? Just now we have got clockwise is positive 37.5 plus 2 into EI, length is 3 meter, 2 into theta B is what? 12 divided by EI, plus theta A is what? 22.2 divided by EI, minus 3, delta is 0, 3. Correct? So what is the moment? 37.5 plus 2 divided by 3 EI, EI get common, so 24 plus 22.2. So what is MBA? What is MBA? Do the calculation. Tell me what is MBA. What is MBA? How much amount? 68.3, positive 68.3 kilonewton meter. Sorry, kilonewton meter. See how just we have solved this fixed flexibility method. There also we got the same. See, in the flexibility method also we got the 68.1. So it is very similar. So like this. So this is second approach. Flexibility is different approach. This is by stiffness also. We got 68.3. Now you calculate this one. Use MBC, M bar BC plus 2 EI by 3. So L 2 theta B plus theta C minus 3 delta by L. So MBC equals to, so fixed length moments what we got? 80, correct? So here minus 80 because here we have anticlockwise plus 2 into EI divided by 4, 2 into 20, what is theta B is 12 divided by EI, theta C is 0 because fixed length, this is also 0. So minus 80 plus 6, 12, 68. Simple. Correct? Now last moment MCB plus 80. I will write now 2 into EI divided by 4, 2 theta C, 2 into 0 plus 1 theta B, that is 12 divided by EI minus 0, 86 kilonewton meter. Just check. See, as per the flexibility also we got 86, correct? Here also we got 86. Here also we got 86. Now same again. Now same equilibrium equation use. We know 68.1. Here 86. Calculate RA, RB1, RB1 and RA. So simple. So like this you can analyze this beam by using a stiffness method. Now tell me you have any. Now the next step is like this. After getting the 68 and 86 here, assume two beams, use equilibrium equation, find out the reaction. Now, you have any doubts? You have any doubts? Yes, students, you have any doubts? Yes, students, you have any doubts? Students, you have any doubts? Are you there or not? Okay. So those who are present, type their roll number in the message box for the presenting. So you can leave the meeting. So the next numerical we will take in the next lecture. So we'll stop here.